So this is a carabiner. A carabiner is a relatively simple system component. So what I'm going to try to do today is try to come up with a renewed version, a rethought version of a carabiner. It's simple enough that I can do it as a first, let's say a first project for Yum Studio. And let's see how it goes. So first of all, how does a carabiner work? Carabiner, what it does is basically it holds things together, right? So you have a hook, a main body, and an opening that you can open, and then it closes itself just to prevent things from coming out. The way that it works is that it has a small spring element here, but the spring element can be created from different configurations. In this case, it's a combination of material plus the shape of the material. So here we have basically a wire, you can see it. It's a small wire, really stiff, I believe it's steel or something like that, material. But then because of the shape that it has, it's relatively compliant and you can push it just with a finger. But this compliance can be created via either the material or the design, the geometry actually of the material. So what I'm going to try to do today and what I'm thinking about is I've always wanted to have a single piece carabiner. So like instead of having these two components, just having a single component, which is in this case would be a single body, and then somehow create this compliant element from the same body as the rest of the carabiner. So let's try to do that. Let's get the sketching going and let's try to think about some dimensions that we would like. I have here another example of a carabiner. This is a bit different. So what it has is basically it has two um, rigid, let's say rigid components, and then internally it has the spring element, but the spring element is located here in the joint here. And that's the difference basically between these two. So this one has the movable body, which is the same as the spring, and in this case you have a movable body plus the spring inside. So both are really good solutions. They really do their job. But what I'm thinking is maybe if we reduce the number of components, this is something that would be maybe easier to manufacture. And also I think it would look quite cool. So yeah, let's get started. You have the main body, which is something like this. And basically what you need to create is some kind of spring here. Usually in engineering, we use this shape to identify springs. And then you can have the main body. And then you can have them connect here. So what I'm thinking is, instead of this, which is basically this being a different body, we could do basically just something like this and try to create this spring element using the same body, but with a different shape. So sometimes when you want to create this kind of compliance inside a material, what you do is you can narrow it, you can change the shape a little bit, you can add curvatures, things like that. That will inherently make the material more compliant. What I'm thinking is sometimes we do see these kind of shapes here, that it's basically like a curvature. The problem with this is that it's something that would be very hard to know for sure what should be the length here and what should be the radius of this curvature. This is something that maybe I can do through simulation, just in simulation software, but it would take a lot of time of simulation, iteration, etc. to validate. I think it's something that maybe I will have to do anyway, because in order to understand what's the correct behavior of this and the stiffness that this element will have, is not something that I can do unless I either manufacture it or I simulate it. So that's something that I can do. It's something that will take longer time, but that's development thing. Let's think first dimensions. Material and design will come later, because that's going to be the driving factor for the stiffness and the compliance of the material. Also the durability of the material, because we're applying cycles into this spring element. If we don't choose the right material, the material will fatigue, and then it will eventually break. Even if at the first try it opens and closes perfectly, the material can fatigue. So what I'm going to try to do is come up with 3 different iterations of different shapes and designs, and try to see if any of them look good. I think if we start with something very simple, just let's say we bring something like just a simple rectangle, like a 4 centimeters, something like 8, so that it's maybe 1:2 ratio on the height. So 4. I need to make sure that I don't take the notebook out of the camera. And then here conceptually, this part is relatively simple. So let's just make some kind of radius here. Then I think here, this I want it to be stiff, stiffer than this section at least, just because I want a rigid back. In this case, I really like this design, this S shape. I think it goes really well. But what I'm going to try to do is, let's try to change to some kind of a rectangle here. And then here, the radius a little bit smaller. So it starts to take shape. This is the tricky part, because I think the easier way to do it would be to add some kind of curves into this design. So something like I drew here. So something like this. Let me just take another color just to so that we can see. So something like this, maybe something like this. That would be the easy way, because this here you have the compliance of this radius plus the compliance of these tiny radiuses, and this is going to create our spring element. Then we can come back and meet with the other part. So what we need to do basically is, I'm thinking that this can be a single body, let's say maybe not an extrusion, but a CNC machine from a single aluminum block, or yeah, probably aluminum. I think steel is going to be a bit complicated, but let's think about that later. So here we need this material to come this way, so this section to come this way, so that whenever these two are in contact, they are closed. But then I think it was the other way around. So this one should come this way, and then this one should come this way, so that we can open this in this direction, right? So something like this. Let's see, let's go back. So here we have, let's say, the continuation of the curvature. And then here we should have the other component. So here, and then here we have and again, here I'm just sketching, so that's why it looks so ugly. But I think we will come to some parts. Here, this is how it looks, this is how it looks, and then here. So the concept is, you have these two parts that come together, and then these, maybe there is a small gap, a few hundred microns. I'm gonna go with 100 microns for this gap, micrometers. So here it's less than a millimeter. Yes, so I think something like that would be enough for material, or the whatever you hook into this not to come out, to close it hard enough. But then you can open it. Something interesting would be if we can add something here. So in the case you want to use it for keys or something like that, right before the spring, we can add like a loop here, and then you can, yes, you can sort of attach keys here into this section or something like that. Just like a keychain, having this loop maybe will help with that. And this would be something solid. So let's say this would be um, single part. Everything would be single part, something like this. Sorry, I'm not the best colorist in the world, and I'm doing this quite quickly, so it may look like shit, but I'm doing it for the video, right? So it could be something like this. Yeah. So, and then you have your single body. So I kind of like this concept. Yeah, I really like it. I kind of like it. The sizing, I think it looks right. It's really quickly. So I think the real dimensions will come whenever we start designing in the computer, and maybe we print a few components, and we start testing it. But I'm kind of liking this concept. Um, Maybe we can do three versions, as I said. One without the loop, one with this, so one without this loop, one without it. So let's see, maybe one with, how to call this, the keyring. Second without, and then the third, I don't know, maybe we can do something like a partial keyring, just to have it, just to be able to put stuff inside, because then maybe if you don't have a keyring, you can put it through here, and then it can go here. The idea really is that this part, the spring part, is going to, this is basically just to hang stuff, not to hold the main part that you want to keep inside the carabiner. Uh, I think this could be it. What I need to think about is really these dimensions, because these are basically the key of the functioning. I'm thinking if this is too thin, it's going to break. But if it's too thick, we're not going to be able to push it. So yeah, that's a tricky one. Let's see, compared to this, looks like it's more or less the same dimensions. I think we should be okay. What I'm going to do now is try to move the design that I did on paper, try to move it to the computer. Okay, now I have created the main body of the carabiner. You can see here. It looks a little bit better than the other one. Look. This is how it used to look. Now it has the step that I was talking about. It has this curvature that I don't like, but now it looks cleaner. It looks a lot better. It looks like it's a single piece. You can see here. Here we have this gap between these two. This is where we will have the opening mechanism. And maybe I'm missing like a small radius here. I'll just put 1.5. And then here also maybe small radius, just so that the general feel is softer when you touch it. I don't like to have rough edges. We will see how we delete that on the rest of the body. But now it looks good. It looks good. It's looking okay. At least it's not something. It's not perfect, but we have the shape. Now what I need to do is work out how the hell am I going to add the spring element here and how to calculate that, because that's going to be very precise work. I need to check really well how to do it, and that's going to be tricky. So that's what I'm going to do next. Hopefully everything goes right. I'll catch up to you later. Hey there. So as you may notice, I'm wearing different clothes, so it's a different day. Actually, it took me some time to finalize the design and do some hand calculations about the curvature that I want for the carabiner, some of the features, etc. But now it's looking good. I'm going to show you right now what I'm talking about, and yeah, let's see. Okay, so basically, this is more or less it's not a final design because it's not going to be perfect on the first time. So there is no point on thinking that this is the final design, but you can see that more or less it has the same concept that I drew before. So you have here on the curvature here, you have the spring element, which consists of a bunch of tiny, tiny, tiny radiuses it's like a zigzag. So what this does is that it reduces the cross section locally, so it makes these parts very compliant. There is a big problem with this design, and the problem is that it's going to generate stress concentrators due to the small vertices or in the angle that we have. And that stress concentrators, it's part of the design because we want it to be compliant, but that can induce failure. And the only way to know for sure if this is going to survive the amount of cycles that we want it to survive is to do simulation or testing. I don't have the capability right now to do the simulation. I'm trying to install a server to be able to do the simulation myself with some open source software. But in the meantime, I thought, okay, I already have the design. I quite kind of like it. I do want to add a few things. So, for example, if we look at this back part of the design, I want to add like a texture here so that you have good grip when you're trying to press the carabiner. And also, I'm not a big fan of this gap. This gap is too small. We need to fix that. So let's. I'm not gonna do that live. It's what I'm going to do now is I'm going to 3D print this part, and I will show it to you on the next episode. Hopefully by then I will have already done some calculations, some simulations, and see which material would work. I'm thinking about aluminum because aluminum is softer than steel. Steel would be better for durability, but maybe we can get away with aluminum. So let's see. I will 3D print it, show it to you on the next episode, and let's see how it goes. And yeah, thank you for listening to me. I think this video became longer than I was expecting to, but I really like the first draft of the design. Let's see how many iterations I will do. And yeah, let me know in the comments what do you think. What do you think of this format? It's the first time that I do this. You can tell by the setup of the cameras and etc. It's a bit weird to me, but it's something that I've been wanting to do for a long time. So yeah, please give me your feedback. It's much appreciated, and see you on the next one.